Okay, let's start today's class. And we'll still work on business model innovation using mathematical formalization. So if we get the core information about how many players in our industry and the total possible value generated by all of them, and use the small v refers to the value generated by each possible value chain. And we can start to infer some basic business laws. And in the last class, first we mentioned about basic case performance. I call it the BCP law. BCP law means for agent I or for firm I, the maximum value firm I can appropriate is less than its added value. And added value can be calculated by information you provide in capital N, capital V, and V. So that three information already can help you calculate added value. That's why added value is very popular in business and strategy and operation context. So everyone can calculate it. So no one can appropriate more than the added value. And the second part, we say in any system, not only basic case performance, we also need to concern on worst case performance. And we get some law to calculate the worst case performance. We look at here. The first, we talk about added value law. Added value law is a necessary condition. It says if firm I has an absolute competitive advantage, and what absolute competitive advantage? Obviously, its minimum value appropriated need to be greater than its opportunity cost. If this inequality works, we say it has competitive advantage. If this is true, will lead to the added value will greater than its opportunity cost. Okay. And the insight we get from this law is added value may not lead to absolute competitive advantage. So we get the first insight mentioned in the last lecture. Even you have added value, you may not get competitive advantage. So these are two different things. And the second worst case performance law is minimum residual law. And this is sufficient condition. It's better, can give us some hint about whether a firm has competitive advantage or not. We can start to look at here. If we know how to calculate minimum residual using this formula, rely on added value information. And if this value list value can be get by firm I greater than its opportunity cost, and we can guarantee this firm has competitive advantage. If not, if this inequality does not hold, we will not be able to know whether the firm has or has not competitive advantage, as we illustrate in the last lecture. So with this basic case and worst case performance law, and we start to get a complete picture about the competitive tension between all the firms in the ecosystem. First, we look at here. Using the basic case performance law, and we can start to guess in an ecosystem without firm I to participate, and there are two possible consequences their firm will face. The first is their firm can appropriate all the value it can get. That is added value. So first possibility is its maximum value appropriation can be equal to added value, because the basic case performance law say this need to be less than added value. The best situation will be pi I maxima equal to AVI. So if this happens, we say firm I is a full appropriator. However, it can also lead to the other possible situation, pi I maxima less than added value on its own. In this case, we can see I use the interval with purple color for basic case performance law. So if this happens, that means the other possible supply chain without involving firm I, they can really make firm I get less value than its added value, as we mentioned last time. So this is a view from maximum value perspective using the best case performance law. We start to see the other perspective using the worst case performance law, and I call it the minimal value view. In the minimal value view, we focus on with the firm to involve in the value chain or supply chain. In that case, again, we have two possible situations. Firm I minima equal to its opportunity cost. If that occurs, it says firm I should not participate in this ecosystem. So firm I has no any absolute competitive advantage in this ecosystem. So he or she decides not to play. Or if firm I has competitive advantage, in that case, worst case performance law start to work. And you can see ACA is a green interval area. So we know pi minima greater than its opportunity cost. Firm I, he or she should play this game. So we have four possible situations are realized by the best case performance law and worst case performance law. But so far, we still have no idea what is pi minima and pi maxima. They are the final value appropriate by ecosystem competition. And we only try to use some structure of ecosystem to infer what it looks like. But we do not know what are they, what numbers they are. So it's unknown. So we cannot use the core information, capital N, how many players, and total value generated by all ecosystem, or the value generated by each possible supply chain. They cannot help us to know pi minima and pi maxima. They only can calculate two indicators. One is added value, and we know it can help us, it cannot help us infer competitive advantage, or minimal residuals, and it does help us know competitive advantage. However, if our worst case performance law violated, that means the minimal residual trick cannot work. So we cannot have enough evidence on knowing whether firm I has competitive advantage or not. If this happens, what can we do? So we want to see the other possibility to using capital N, capital V, and the small v to get further information. In that case, we rely on the structures of competition in ecosystem. We look at the first structure. In the last week lecture note, we mentioned there is a spatial structure called perfectly competitive market you learn in the basic economics and marketing class. And we define what a perfect competition refers to. The firm I's minimum value can be appropriate equal to the maximum value it can be appropriated. If this happens, the firm cannot bargain between pi minimum, pi maxima, and this helps us to get the other sufficient condition. If each firm's added value added up together equal to capital V, the total value generated by the entire ecosystem, and then we can guarantee the realized value appropriate equal to pi minima, equal to pi maxima, equal to added value. In this case, added value can be equal to the final value appropriate by each firm. So if your market has this spatial property, such as perfect competition, and we get the answer. We know what are pi I and pi j and pi for all the firms. If this trick does not work, if we still cannot make this condition works, we need to use the next trick. And this trick, actually, you learn before in basic management. Okay, so now we want to use formal language to describe how do we use the value chain in data analysis. So first, we define what we mean partition. A partition of an ecosystem, capital N, is a collection of value chains, separate value chains. And we call this collection as S. For this capital S, it's a set of G1, G2 to GK, K different supply chain or value chains. So I have K supply chains, and each supply chain is a group. And the set of them is a partition I call S. And I make even stronger condition as you learn in your management textbook. If you want to use value chain analysis, implicitly, you already make the following assumption. If I have two value chains and they cannot have a common firms, they cannot have one firm work in two different value chains. So there is no any player involved in two different supply chains. And second assumption is, if I put the members of each supply chain together by union, and the total number of this union need to be equal to capital M. We look at example here. If now I have 5 firms in my business ecosystem, and if I can find out one partition, such as firm 1 and firm 2 forms a supply chain, firm 3 work on its own, 4 and 5 form the other supply chains. In this case, you can see I have 3 supply chains, and these 3 supply chains have no common players in each of them. Also, if I put the union of these 3 groups together, I get the original capital N set. So this is the mathematical formalization of value chain analysis. And further, we can use matrix language to say it. If I want to use the matrix to describe this partition, how do I do it? So I have 5 players. 1 means firm 1 plays in this value chain or not. 0 means firm 1 does not want to play this value chain. So you can see the first value chain consists with player 1 and 2. So its matrix representation will be 1, 1, 0, 0, 0. So I apply the same logic for the second value chain with player 3 only, and do the addition of separate matrix, and you can see the sum of these 3 value chain together equal to original, the capital M. So this is the way we operate in matrix. Is that okay? Any questions so far? Can you see it? So what I'm doing here, actually we can write down as a mathematical formalization using matrix is this. And if you have time, look at last week lecture note, and you can see how do I define the matrix for each supply chain. And this formulation equal to what I have done here. So any question? Is that okay? If you accept partition idea from value chain, and now we want to define the other definition called partition the value interaction. Yeah. And what does that mean? That means a strategic interaction, capital M, capital V, and V is a PVI, partition the value interaction, if there exists some partition. Okay, if there exists at least a partition. And what is a partition? The partition means no different supply chains can have the same player, and the union of all of them need to be equal to original ecosystem with the value generated by each supply chain or value chain, when we add up them together as a sum, this added up value need to be equal to the total value generated by entire ecosystem. Why we want this property? Because this property can help us to simplify value chain analysis. Let me say it again. If we can find out a partition, just one partition, you may have 2 or 3 partitions. We just pick up one. And then one partition can result in this adding up property. The value generated by each supply chain, the sum of them equal to capital V, and we will be able to get the next law. That law is the principle of market segmentation. You always use a lot in the marketing. So suppose our strategic interaction is a partitioned value interaction, and I find out at least one capital S as a partition or market segmentation. So when you do marketing, usually you try to segment your market into very small so you can do analysis. So this actually is a way we usually do in marketing analysis. So if I can identify one segmentation or partition, and the competitive distribution of pi, or the value appropriate by each firm, will be a competitive distribution or equilibrium only if the value appropriate by each firm in each supply chain and put them together will be equal to the total value generated by their supply chain. Now, I use only if, and it confuses you maybe a little for logic. So only if is a reverse logic concept, and I put its definition here. Statement A only if statement B equal to if A is true, then B is true. So if I put only if, in the common human being language, I need to use A as a condition, and then B is outcome. So we can restate again. This law of market segmentation said, if now there is a partition, and that partition guarantees each firm generated the value from its supply chain, and all the firm's value in that supply chain equal to VG. VG is the total value generated by that supply chain, and it can be a market segmentation. The reason is, if it is PVI, and I already know VG and its sum together equal to capital V. In that case, we have a nice insight. And the insight is, when the industry is a PVI, or you can say strategic segmented in the marketing sense, value is created and appropriate within each value chain. So that no value produced in one chain can lead to the other chains in the entire ecosystem. Okay? So sounds a little bit tautology, but it tries to say, if you use market segmentation as a tool to do industrial analysis, at the end, you make assumption each firm's value in one segment cannot lead to the other segment. So every firm in the ecosystem cannot play a platform strategy. What the platform strategy mentioned in the last time, the industrial speakers, the Dr. Yang. Dr. Yang say, if you build a platform and you can make different suppliers and different the buyers in a different timing to form different supply chain. But market segment actually forbidden this possibility. So if you use market segmentation analysis, you do not consider platform strategy. And math can prove it. Okay, I put the usefulness here. Why it is useful? When the best case performance law and worst case performance law are not useful, they cannot help you to judge whether each firm has competitive advantage or not. And we want to get more information about how to infer different players have competitive advantage or not. So this is not only necessary but also sufficient condition for us to check out the competitive advantage. But can we calculate this by hand? Of course not. Of course not, because MVI is a solution to this minimization problem. And if I have 1,000 firms, how can I solve this system of inequality by my hand? It's impossible. I need to rely on computer. So it seems like this definition for I minimal total value help us to identify true competitive advantage for each firm in the ecosystem. But this definition cannot be solved by hand. So we start to see how do we solve it on computer. If you learn management science model or optimization in the current class in our NTU BA, or you learn in electrical engineering for optimization, I think you know this is a linear programming problem. And I believe some of you know this problem can be solved by Excel. But I tell you one example, because now I'm mentor for the year 3 BA students. And one student come to see me for writing reference later for his internship. And she mentioned one very interesting experience to me. When she did the management science model class, and he got data for all the park space capacity in front of the female student accommodation, I think number 9. And she wants to use linear programming model to solve assignment problem for how many bikes can park on the space in front of the number 9 female student accommodation, the dorm. And they spent over 2 months, use Excel to solve it, and then they cannot get any solution. The reason is they have more than 100 variables. And after over 60 variables, Excel crashed. So in this experience, I think she applied the major supply chain internship in a global company. And I asked her to write down this experience. The reason is if you want to make in charge for the global supply chain position in one big company for PC, if you only use a tool can solve only 60 or less parking space for their supply chain. Are you kidding? So that's why we use different tools. We use R, and we can solve problem over 10,000 variables. So we will not crash. Do you know what I'm saying? So we want to use more stable tools. Now we start to see the code Jen wrote. So first, I clear the memory, and I install package called LP-solve. So I want to use the professional solver in R. I want to formalize our problem, so we work on this problem. Do you remember this problem? We have 3 players, and we have different supply chain combination. We can formalize this as a minimization problem using LP. And I do not have much time today, but I do believe go back, because you already learned the 4 tutorials in R on YouTube made by our TA. I believe you can understand the code within 30 minutes if you put efforts already. If you still do not understand it, write email to our teaching team, and we can make a appointment with you. So simply speaking, first, I set up this LP solving problem as a minimization problem. And I have 3 variables. So each variable with coefficient 1. So I put the objective function as a sum of their combination with coefficients O equal to 1. And then I use a matrix to write down 3 inequalities. Do you remember? I have 3 constraints, and each of them is greater than or equal to, greater than or equal to or equal. And this is coefficient on the right-hand side of each inequality. So roughly, I do believe you are all very clever. You look at this code and look at the problem on our slides, you can figure out how do we set up this LP solving problem. So we solve it. We run it. We solve it. We get a solution. So immediately, we already know that if this is firm 1, do you remember the problem? I want to drive firm 1 out. So I set up firm i's value equal to 0. And the i's total minima value is 17. So in order to achieve 17, I need appropriate minimum value for firm 1, 0, firm 2, 9, firm 3, 8. So I do not calculate by hand. I also ought to solve it. So we already get the solution for first problem by setting up pi 1 equal to 0. So James start to use an alcohol to create a table to do 1-by-1 analysis for these slides. So we see what she is doing. So now we can see, do you remember, I tried to use hand to calculate 1-by-1 by pi 1 equal to 0, pi 1 equal to 1. So Jen now create a table. Okay, we can see what table looks like. So we created one empty table, and we run the problem for 7 times. And do you remember, for each time, we set up different value for firm 1's value. The first is firm 1's value equal to 0. Second step, firm 1's value equal to 1. The third step, firm 1's value equal to 2. So until we try the value of firm 1's value make the value gap equal to 0. So we start to do the procedure. So you can see the first step, I set up firm 1 equal to 0. I set up firm 1's value equal to 0. Then we solve it. So now we fill in the solution of the first minimization problem of firm 1's value equal to 0 here. Firm 2 get 9. Firm 3 get 8. And the total value cannot be greater than 10. And minimum total value is 17. 17 greater than 10, so firm 1 has competitive advantage. Okay, so we keep repeating this procedure. Now I set up firm 1's value equal to 1 here. And then I set up firm 1's value equal to 2. So I want to run this optimization problem for 8 times. But if you are from the computer science and electrical engineering background, I do believe you can find a better way using for loop to do it quickly. Now I do not use a for loop. But yesterday, when I worked with Jen, I realized this can be written by for loop rather than running 8 times. And I leave this practice to you on your own for your future data science career. So at the end, we run the optimization problem 8 times. You can see we solve the problem. At the end, we get value gap equal to 0 by setting up till the firm 1's value equal to 7. OK, so any questions so far? Go back to practice, and you definitely will enjoy it. And now we move to the maximum value. So I'm doing the same thing. I use the linear programming solver. I still use minimization as my problem, but now I make different assumption. Before I say firm i's value is equal to its opportunity cost. Now I change to firm 1's value is equal to its added value. Others are the same. So you can see we solve it. So what this case is saying, if i's total maximum value is 10, 10 is equal to the total value generated by the entire ecosystem, that's 10. And we will say, firm I can appropriate all the value it has. Okay, this is the way I wrote this morning. And then this is code written by Jen, and they will get the same result. I put them together so you can go back to check. Using different logic, you can get the same result. So one is written by me, the other by Jen, but all get the same result. So when we have the R using LP solve package, we can solve these two problems very easily. So this is made by hand, and we already show how to solve it by R. And we give some final hint. So if you already get the insights from these two minimization problems, actually you already know how to solve pi minima and pi maxima by computer. In the previous 3 lectures, we spent a lot of time to tell you how to look at problem structures to get results without using any calculation. And now it's different. We can use computer to do it. So pre-theory just rely on our insights to mathematical property of business ecosystem. Now we want to solve it by computer. Do you remember last week example we say an ecosystem with 3 players? One is Amazon, the other is Facebook, the third is Google. Have you remembered this? Do you remember the conclusion at the end? We say, from the example we set up, Amazon has absolute competitive advantage using the worst case performance law. However, Facebook and Google, we cannot infer whether they have competitive advantage or not, because worst case performance law does not infer us the answer. So we work on the same problem. If all the laws using our brain power does not work, now we use computer power to do it. So I work on the same problem. We have Amazon here, Facebook here, and Google here. And now I want to calculate minimum value appropriate by Amazon. So I set up Google and Facebook to 0, because now I only want Amazon's minimum value. I put the same constraints for feasibility and stability as what we did last week. And we put the inequality condition here. And everything is the same as what we did last week, and we solve this problem. So this is the same as what we did last in the previous lecture. So interestingly, we already know that Amazon's the minimum value is 50 here. And now I work on the maxima problem. Maximization problem. So I still work on Amazon, but I want to calculate Amazon's maximum value can be appropriate by ecosystem competition. So I get result as Amazon's maximum value appropriate as 200. Okay? So after doing this, I just use some simple simple column bind using our function, and I can put Amazon's pi minima and Amazon's pi maxima here. So I know Amazon's pi minima is 50. Amazon's pi maxima is 200. Does Amazon has competitive advantage? Can you see? Amazon has competitive advantage. Why? Minimum value is 50. Opportunity cost is 0. Amazon has competitive advantage. Okay, so I do this again for Facebook. So now I want to work on Facebook problem in the ecosystem. I set up objective function for Amazon and Google equal to 0. I focus on Facebook. And I do the same calculation for minimization problem and maximization problem. And I create a table using cbind. And I know the Facebook minimum value is 0, maximum value 50. So Facebook has no competitive advantage. I use the same procedure work on Google. I set up Amazon is 0, and Facebook is 0, and the Google is here as 1. So I do it again. Okay. I first look at here. I see for Google, minimum value is 0, so Google has no competitive advantage. Now I use rbind to put 3 pi minima, pi maxima together. At the end, I solve entire problem by here. 1 is Amazon, 2 is Google, 2 is Facebook, 3 is Facebook. No, 2 is Facebook, 3 is Google. So we can see only Amazon has competitive advantage, but Facebook and Google, they do not have competitive advantage. They may appropriate better value, but this is not guaranteed. So we can say in this alliance, Amazon plus Google plus Facebook, Amazon always win, but Facebook and Google may not. Depends on how they bargain between value from 0 to their maximum value appropriated. So Facebook and Google need to bargain, but Amazon does not need to bargain. Now we already close to the very nice end. Now, even we do not really comprehend all the mathematics or mathematical properties in the previous 4 classes. If we know R, we still can solve it. Isn't that lovely? Use the computer power to replace brain power. Yeah, maybe not too bad there. So the conclusion for today's lecture before invited talk is, today we formalize the detailed discussion of value appropriation. We talk about why market segmentation is important in marketing and strategy and business modeling. The reason is it uses decomposition principle in engineering to help us reduce complexity we face in analyzing business situation. After doing this, we start to use I total minima value and I total maximum value to talk more about with me versus without me. I talk about with me versus without me in more detailed sense. And we start to see why we need solver to do linear programming rather than using handwriting. Because handwriting and hand calculation cannot help us to solve problem if worst case law does not work. Then we use our package to solve minimum value, maximum value, and bounds, pi minimum, pi maxima, in a second, just using computer power, even we do not know all the math. So at the end, I think now we are comfortable on using R to do business model analysis in your group project, I do believe. Okay, and in this week lab, and our TA already made YouTube for linear statistical model for not only simple linear model, also about discrete choice model. Please enjoy it. If you enjoy it and know all how to do it, and today's R code for linear programming is easy for you. And Jen already proved it. Assigned reading. For this week assigned reading, I put the package LP solve menu and one very detailed menu for how to use LP solve. You may not need to read all of them. Just skim them to find out the part you need. And if you still do not understand some parts in today's code, and write email to our teaching team, and we can discuss with you person by person. And please read the R tutorial for chapter 7 and 9 because they will appear in your midterm exam. Okay, so that's it. And thank you. So we take 10 minutes break before the invited speaker